This is BYU Math 112. In this video we will discuss textbook section 3.3, exercise number 40, which reads the limit as x approaches 0 of the sine of 4x over the sine of 6x. We'll be using the fact that if we have the sine of theta over theta, we take the limit as theta goes to 0, we get a 1. So what we want to do is think about how to transform this sine of 4x over sine of 6x and make it look like sine of theta over theta. So we have a sine of 4x on the top, which means we're going to need a 4x on the bottom. We have a sine of 6x on the bottom, so we're going to need a 6x up on the top. And so what we want to do is we're going to multiply by a 4 on the top and the bottom. We're going to multiply by a 6 on the top and the bottom, and then we're going to multiply by an x on the top and the bottom. And so what we then have is limit x approaches 0. And we're going to write these in a certain order. Since we're multiplying all of these things together, they're all going to be numbers. We know that we can use the commutative property to swap places on the top or the bottom. So what we're going to write is the sine of 4x times 6x times 4. So we've just taken those things and grouped them and written them in a certain order. And then on the bottom, we're going to write 4x here. We're going to write the sine of 6x here. And then what we have left is a 6. So we've taken the 4, the 6, and the x. We've grouped them and written them in certain orders. And since we have continuous functions here, we can rewrite limit x approaches 0 of sine of 4x over 4x times the limit as x approaches 0 of 6x over sine of 6x times, and then 4/6. We can divide both of those by 2 and get a 2/3. And then we're going to make substitutions. For this first one, we're going to let theta equal 4x for the first part, and then we're going to do theta is equal to 6x for the second part. And so what we note is that as x goes to 0, theta also goes to 0 in both of these parts. And so for the first one, we're going to make that substitution everywhere. So we have the limit as theta goes to 0 of sine theta over theta times the limit as theta goes to 0 of theta over sine theta times 2/3. We did use the fact that the limit of a constant is just equal to a constant to pull out that 2/3. I neglected to mention that up in our third step, but that's what we did. And so now, using the fact that we copied here, for this first part we're going to get a 1. For the second part we're going to get a 1. The third part we still have our 2/3. And so this limit is just going to be equal to 2/3. So again, this is the fact. I would memorize this one because it comes in handy quite often. The limit as theta goes to 0 of sine theta over theta equals 1. So we want to take what we are given and figure out how to transform it so that we get the same thing on the top as we get on the bottom. We have a 4x on the top, we want to be able to get a 4x on the bottom. We have a 6x on the bottom, we want to be able to get a 6x on the top. And then when we split up our limits, because of continuity, we can get 1s. And everybody loves multiplying by 1s because they're easy. And that's how we do problem 40.